Well, good afternoon, ladies and gentlemen. My name is Art Benjamin, and I am a mathemagician. What that means is I combine my loves of math, or I should say maths, and magic to do what I call mathemagics. But before I get started, I've got a quick question for the audience. By any chance, did anyone here in the audience happen to bring with them this afternoon a calculator? If you have one, perhaps on your phone or somewhere, and you're pretty comfortable using it, raise your hand. I'll need a couple of people to help me out here. I see 1, 2, and perhaps one more. 3. Would the three of you bring out your calculators and join me up here on stage, and let's give these volunteers a nice round of applause. Come on up. Great. Over on this side, please. Awesome. Now, since I have not had the chance to work with these calculators, I need to make sure that they are all working properly. Would somebody get us started by giving us a 2-digit number, please? How about a 2-digit number? Just yell one out. 74. Oh, okay, that's fine. 74. And another, how about another 2-digit number? How about on this side? 39. Multiply 74 times 39 on the calculator. Make sure you get 2,886, or the calculators are not working. Do each of you get 2,886? Give them a round of applause. Now, I notice that took some of us a little bit of time to get the answer. That's okay. I'll give you a shortcut for multiplying even faster on the calculator. There's something called the square of a number, which most of you know is taking a number and multiplying it by itself. For instance, 5 squared would be 25. 6 squared would be 36. 73 squared would be something else. Yeah. So now, on most of these calculators, they have little shortcut buttons that allow you to square numbers even faster. What I'm going to try and do is to square, and you might test it and make sure you could square 5 or 6 with it, but what I'm going to try and do is to square in my head 3 2-digit numbers faster than they can do on their calculators, even using the shortcut method. What I'll ask is 3 people, how about in the third row here, 1, 2, 3, each yell out a 2-digit number, and if you would square the first one, the second, and the third one, I will try and race you to the answer. So quickly, a 2-digit number, please. 24, great. Next. What was that? 98, and one more. 26. Would you call out your answers, please? 576. 9,604. 676. Give them a round of applause. Let me try to take this one step further. I'm going to try to square some 3-digit numbers this time. I won't even write these down. I'll just call them out as they're called out to me. Anyone at all call out a 3-digit number? Anyone on our panel verify the answer? Now, if I get the answer right, give me a big thumbs up. If I make a mistake, let me know and I'll try and fix it. A 3-digit number, anyone? 576 is 331,776. Yes, good. How about another 3-digit number? Sir, a 3-digit number.
103.
103 is 10,609. Way too easy. Another 3-digit number. 3-digit number, please.
125.
125 is 15,625, but that's 5 to the 6th power, so that was easy too. How about another 3-digit number, sir? 985 is 970,225. Yes, thumbs up if it's right. One more 3-digit number, sir.
926.
Ooh, 926 is 857,476. Thank you very much. Let me try to take this one step further. I'm going to try to square a 4-digit number this time. Now, I'm not going to beat you to the answer on this one, but I will try to get the answer right. To make this a little bit more random, how about we use the 4th row, 4 people. Each of you call out a single digit between 0 and 9. That will be the 4-digit number that I'll square. 1, 5, 7, 7. 1577. This will take me a little bit of time, so bear with me. 3 million. 486,929? No? Okay, wait, don't tell me if I made a mistake. Was it what number was 1577? Oh, wait. Okay, let's try that again. 3 million, so far so good, Oh, is that where I went wrong? Okay, I never make a mistake there. Okay, 1, 2, okay, 3, 1, 1. Oh, 2 million. Was everything else right? Yeah. Thank you very much. What's 1 million off? That's all I ask. Now, I would attempt to square a 5-digit number, and I can, but unfortunately, most calculators cannot. So, since we've reached the limits of our calculators, although some of yours may go higher, I'm going to try to conclude the first part of my show by trying something even trickier. Let's take the first number on the board here, 576. Would you each enter 576 on your calculator? And instead of squaring it this time, I'd like you to take that number and multiply it by any 4-digit number that you want. But don't make it too easy like 1,000 or 1, 2, 3, 4, but just some random 4-digit number. So you should have as an answer either a 6-digit or possibly a 7-digit number. How many digits are in your answer? 6 or 7 digits? 7? 7, 6. Is there any possible way that I could know what 6 or 7-digit numbers they have? Say no. Good. Then I shall attempt the impossible, or at least the improbable. What I'd like each of you to do is to call out for me any 6 of your 7 digits, or in your case, 5 of your 6 digits, in any order you'd like. 1 digit at a time, I shall try and determine the digit you've left out. So starting with your 6-digit number, call out any 5 of them, please. 80938. Did you leave out the number 8? Yes, that's 1. You've got a 7-digit number called any 6 of yours, loud and clear.
472584.
Did you leave out the number 6? That's 2. The odds of me getting all 3 of these right by pure guessing would be 1 in 1,000, 10 to the 3rd power. Okay, any 6 of your digits, really scramble them up this time.
944544.
Did you also leave out the number 6? Great! And let's give all 3 of these people a nice round of applause. Thank you very much. Thank you. Well, for my next number, I have another question for the audience. By any chance, does anyone here happen to know the day of the week that they were born on? If you think you know your actual birthday, raise your hand. All right, starting with you, what year, if I may? 1992, and what month? July what? 3rd. Was that a Friday? Yes, excellent. Somebody else. Yes, sir, green shirt. What year? 1992, and the month? June what? 30th. Was that a Tuesday? Excellent. Somebody else. How about you? What year? I'm sorry, so what year was it? 1995. And what month? June what? 26th. Was that a Monday? Excellent. All right, I see a hand up in the balcony. Young lady. Let me try something different here. You're sure of the birthday. What year was it? What day of the week was it? Tell me in advance the day of the week. Thursday. Okay, and what year was it? 2002. Did it happen to be on May 2nd? Yes. Now that's my daughter. I knew that one. I was there for that one, for that Thursday. Anyway, I never tried that before, but whatever. Do we have anybody here who does not know the day of the week they were born but would like to find out? Okay, now let's see. I see yours. Now, of course, if you don't know what it is, I could just make up an answer and you'd probably believe me. But I don't want you to have to do that. So I come prepared for that situation. There is an app for everything these days. So I'll ask one of you here just to take this. And so give us your year and then type in the year right in that blank spot. What year? 1995, so type in 1995, great. And what month? September. Press the September button there, and that should give you a calendar. September what? 21st, I believe, was a Thursday. Can we get confirmation? It was Thursday. Good. I'll tell you what. You know what? Since you have the app with you, let's try something trickier. The app actually goes as far into the future as 3000, as far back into the past as 1600. Don't go below 1600 because then we get off the Gregorian calendar and that messes me up a little. So what year would you like? Choose a year between 1600 and 3000. Go ahead. 2730. So enter 2730 into that. And what month would you like? June what?
The 13th.
13th. Will that be a Friday? Yes, and it'll be cloudy on that day too, if I'm not mistaken. Thank you very much. In fact, anybody else who wants to find out their birthday, see me in the lobby, perhaps in the break or so. I'll be more than happy to tell you. Now, I've got just a little bit of time left, so I'd like to do one last thing for you that I alluded to earlier when we had the other calculators on stage. I'm going to try to square a 5-digit number, requiring, if you have it, a 10-digit calculator or higher. Feel free to bring out your calculator at this point. But to make my job more interesting for you as well as for me, I'm going to do this last problem thinking out loud. So you can actually, honestly hear what's going on in my mind while I do a calculation of this size. Let's create a 5-digit number. How about why don't we just go up with this aisle? The first 5 people along the aisle, each give me a single digit. That will be my 5-digit number. 3. 7. 6. 9. 1. 37,691 squared. Yuck. Let me explain to you how I'm going to attempt this problem. I'm going to break the problem down into 3 parts. I'll do 37,000 squared plus 691 squared plus 37,000 times 691 times 2. Add all those numbers together and with any luck arrive at the answer. Now let me explain one more thing. While I do this calculation, you might hear certain words as opposed to numbers creep into the calculation. Let me explain what that is. This is a phonetic code, a mnemonic device that I use that allows me to convert numbers into words. I store them as words and later on retrieve them as numbers. I know it sounds complicated. It's not. I just don't want you to think you're seeing something out of Rain Man here. There's definitely a method to my madness. Definitely. Sorry. One last instruction for my judges with calculators. Now, who's got an answer in front of them? Raise your hand. Okay, enough of you. There is a 50% chance that I will make a mistake on this problem. If I do, don't tell me what the mistake is. Just say you're close or something, and I'll try and figure it out, which can be pretty entertaining in itself. If, however, I am right, whatever you do, don't keep it to yourselves. Make sure everybody knows that I got the answer right, because this is my big finish, okay? So without any more stalling, here we go. I'll start the problem in the middle with 37 times 691. Now let's see. Oh my gosh, so that's 700 minus 9. I'll take advantage of that. Now 700 times 37 is 25,900. 37 times 9 is 333. Subtract the 2 to get 25,567. 25,000, do I believe that? Yeah, 25,567. Double that to get 51,134. 51,134. Okay, 51,000 becomes light tomorrow. Light tomorrow is 51,134. That seems right. I'll go on. Next, I do 37 squared, which is 1369, so I can say 1 billion. Take the 369, add that to light. Is there going to be a carry? No. 369, add that to light to get 420 million. Tomorrow. Okay, next we do 691 squared. That's 700 times 682 plus 9 squared. That's 477,481. Raft, if I need it, raft. Take the 477, add that to tomorrow to get 611,481. Yes! Good. Thank you all very much. I hope you enjoyed Mathemagics. I'm Arthur Benjamin. Thank you.